Hi, I'm Josh.
And I'm Jackson.
This is Enigma Explained. So, in this one, we are going to walk through the extended example down here. But first, we're actually going to touch on something we accidentally skipped, which is the plug board. So, kind of to make things more difficult and kind of add more possible combinations, Enigma incorporated a plug board that kind of is the first sort of contact between the keyboard and the rightmost wheel. This was not a moving rotor. It was configurable in the sense that the operator could choose to connect two letters by kind of putting some cables between them. And if these letters were connected, so in this example, if like A and P were connected, then any P's typed would be actually sent into the machine as A, and any typed A's would be sent in as P's. And then on the encryption, so coming out of the machine, if a letter was encrypted to P, it would actually display as A, and likewise, if a letter was encrypted as A, it would display as P. So kind of just an extra step, and this is relevant because it's part of the project, and in our example, we will see that some letters are connected in the plug board. So, to get to our example, we kind of have some setup here. We have some rotors we're using, and we can see those rotors here. So it looks like we are using B, beta, 3, 4, and 1 in that order. So B, beta, 3, 4, and then 1. We can see their permutations here. So here we see for B is a reflector, because you remember the reflector has to be in position 1. So we see a reflector here and its permutations. We see beta's permutations here, and then 3, 4, and 1. So we see 3, 4, and 1. Now, for our moving rotors, which is 1, 3, and 4, we also see which notch they are at. So 1 has a notch at Q, 3 has a notch at V, and 4 has a notch at J. And that's not too relevant for us because we are only going to be rotating once in our example. It's just important to know the notches are here. Okay, so we also see the initial positions of the rotors. So our example earlier, our short example, everything started at A, and A, if you remember. Now rotors 2 through 5, which is beta, 3, 4, and 1, are starting at positions A, X, L, and E. Finally, part of the setup, in the plug board, Y and F and Z and H are steckered or interchanged. So typed Ys go in as Fs, typed Fs go into the machine as Y, and outcoming Zs light up as Hs, outcoming Hs light up as Zs. So we will see this. Now we are going to type the letter Y, and we actually have some little presentation here to help us do this example. So we have an example. We have our Enigma setup, which we talked about, rotors 1 through 5 in that order. We have our initial settings for beta, 3, 4, and 1. We have our plug board. We have our permutations, which we can reference later on. Maybe we'll do this full screen, actually. Let's see, or side by side. That's what I meant. I'm going to put this over here, and we will keep this here. Perfect. Okay. So, present. Nice. So, we have our permutation table here. We can also reference this over here. And for each rotor, when we are translating, we're going to be looking at what is the current setting of that rotor, what position are we entering, and we're going to do this by index of the letter in the alphabet. We're going to see which contact are we entering, and we remember from the video on the contacts that when we enter the rotor, if we enter at position P, we have to add the setting and take the mod of the alphabet size to get what contact we entered. That was when we talked about this up here. We are going to see which contact we exit, which is essentially the translation. So, here A contact would exit at the E contact because the permutation permutes A to E. And then finally, to see which position we exit, we are going to subtract our setting and take the mod of the alphabet size just according to So on our example here, the B setting, something entering at C contact would actually enter at the B position because we did C -1, which is the setting B. So let's get started. So the Y key is pressed, and the rotors will all attempt to rotate before encrypting this Y. So the pawls will move and try to engage with their ratchets, and if we remember, our rotors, where is it? Our rotors 3, 4, and 1 have notches at Q, V, and J, but the initial positions were X, L, and E, so nothing is close to a notch. So which rotor turns? That is only the fast rotor. So only the fast rotor succeeds, advancing from E to F. So this is now in the F setting. And we have some little visual here. So this is our right rotor. This is actually the plug board. Then we have rotor I, which is currently at setting F. We have rotor 4, currently at setting L. Rotor 3 at setting X. Beta is in its A setting. We have our reflector B. Now in our plug board, since we are typing Y, and Y is connected to F, typed Ys are going to enter the machine as Fs. So we have our F here. We enter the right side of rotor 1 at position F. The contact we actually hit is F plus the setting. So F plus F is 5 plus 5. So 5 plus 5, which is 10. So that is contact K. Now, in the permutation for rotor 1, K maps to, what does K map to? K maps to N. So we see K will map to contact N, and to actually exit this rotor, we are going to subtract the setting, which is F, which has its exit at position I. So we just did this first step here. So F enters at position 5, hits contact 5 plus 5, that's K. Rotor 1 converts K's to N's, and when we exit, we are going to subtract the setting, giving us an I. Okay, now we're going to enter the right side of rotor 4. So I enters the right side of rotor 4 at position I. Rotor 4 is in setting L, so that is the 11th setting. So we're going to have 8 plus 11, which is 19, which means we're going to hit contact 19 here, T. According to the permutation for rotor 4, T is translated to G, which is 6. And we are going to subtract the setting from the contact before we actually see which position a signal is outputted at. So here we have 6 minus 11, which is -5. But when we take the mod 26, so mod our alphabet size, we will get 21. So G is actually going to output a signal at position V. Now we're going to put this V into setting 3, into rotor 3, and rotor 3 is at setting X, and X is the 23rd letter of our alphabet here. So we enter at position 21, but we're actually going to hit contact 21 plus 23, which is 18, mod 26, and that is letter S. So you'll see letter S here. According to rotor 3, S is translated to G, and to see what position we exit at, we are going to subtract the setting from G, so we will get -17, which is 9 mod 26, so we output a signal at position J. Now I've done this a few times, we're going to go a little faster now. So beta is in position A, so it's going to take in J and translate J to W, and we can see that from up here. So beta translates J's to W's. We're going to hit our reflector here, B, and B translates W's to H's, and then to send this H back into beta on the left side now. So H goes into beta, beta translates H's to X's, which we can see from the permutation. Now we're going to do the same math on the way back. So we're still going to say, when I enter a rotor at position P, I'm going to add the setting and take mod alphabet size to find which contact I actually hit. And then when exiting a rotor, I'm going to subtract the setting from the contact to see which position I output a signal at. So X when we take the mod, do some math here, actually hits the U contact. U gets translated to W according to rotor 3. W will come out at position Z. Again, doing the math here, go ahead and double check this later. We're going to send this Z through the left of rotor 4. Z is actually going to hit contact K. So we're going to take the setting L. We're going to add this to our position, take the mod. We're going to get contact K. K will be translated to U, and U will actually output a signal at position J. Now we are sending this J over to the left side of rotor 1, so we are here. J will actually hit contact O, so 9 plus 15, which is translated to M and comes out at position H. Finally, we send this H into our plug board, and if we go all the way back to the beginning, we remember Z and H are interchanged in our plug board, so this H will actually be outputted as Z. Therefore, Y is converted to Z. So if anything didn't make sense here, be sure to post, probably on Piazza, asking about questions about this video. Essentially, we came in through the plug board, went through all of our rotors in this direction, hit the reflector, and came back out through our rotors, accounting for the rotor settings along the way. So I'll cut this short. It's been a long one. Hopefully we'll see you in the next video. Thanks.